In this video, we present a toolkit for active games. The toolkit is based on our classification, which abstracts input from hardware, providing a better understanding of the interaction itself. Our toolkit simplifies input handling in active games and allows developers to write code independently of input hardware. We define an active game as a video game involving physical activity. These type of games have become tremendously popular in recent years with systems such as the Nintendo Wii, Sony's iToy, and Dance Dance Revolution, as well as recently announced motion capture systems such as the Wii Motion Plus, the PlayStation Move, and Microsoft's Project Natal. Our synthesis and analysis of existing active games reveals 6 common forms of input interactions: gesture, stance, point, power, continuous control, and tap. This classification provides a better understanding of the interactions themselves. In addition to its theoretical use, our input classification is useful in the development of active games. We have demonstrated this through the ongoing development of the General Active Input Model, or GAIM, toolkit for input handling in active games. The GAIM toolkit allows developers to program active games based on our input classification. The toolkit is divided into 3 layers. Here we see an example of the GAIM toolkit's iPower interface providing a single power property. The toolkit currently provides 2 implementations of power input, one based on stationary bicycles and the other based on heart rate. To illustrate the effectiveness of the GAIM toolkit for supporting a variety of devices, we modified Microsoft's XNA racing game to become an active game. The racing game allows a player to race a car around a selected track. In the original game, the car's direction is controlled by the left analog stick, and speed is controlled by the right trigger on an Xbox 360 controller. In our modified game, speed is controlled by the player's physical activity as measured by the speed at which she is pedaling a bicycle or how closely she is matching her target exercise heart rate. We now demonstrate the various inputs possible in our modified racing game. Here we see the view of the player using the PC Gamer bike for active input. In this case, the faster the player pedals, the faster his car will go. Similarly, here we see the player using a Tenturi recumbent bicycle to power his car in the racing game. Alternatively, heart rate can be used to power the player's car. By jogging on the spot, the player is able to increase his heart rate. The closer his heart rate is to his target exercise heart rate, the faster his car will go. As a second example, we use the GAIM toolkit to modify the XNA SpaceWar game to become an active game. In the game, a player uses an Xbox 360 controller to maneuver a ship around obstacles while trying to shoot her opponent's ship. In our active version of SpaceWar, a Wii remote captures the gestures of a player to fire weapons, and a Wii balance board measures the player's stance, which is used to steer the ship. Here we see the active version of SpaceWar in action. Leaning left rotates the ship to the left, and leaning right rotates the ship to the right. Leaning forward accelerates, while leaning backwards slows the ship down. The player vigorously shakes his hand up and down to fire the ship's weapons. We believe that our input classification is the first approach at abstracting interaction in active games. Our modification of the XNA racing and SpaceWar games using our GAIM toolkit illustrates how active games can be developed independently of input hardware, as well as the portability of such games.